Acid value of oils by titration for biodiesel. The acid value test is used twice in biodiesel production. The first time determines how much catalyst to use in the biodiesel recipe, subject to the properties of the oil. The second time determines how long the fuel's shelf life will be subject to the amount of free fatty acids in the biodiesel. Oils and fats tend to break down through oxidation over time to form free fatty acids. When these feedstocks are used to make biodiesel by transesterification, the free fatty acids quickly consume some of the catalyst to form sodium and potassium soaps. Too much soap can complicate the separation process and reduce yields by carrying some of the fuel into the glycerol phase. Soaps must be removed from the biodiesel by water washing or some other purification process. Residual soap in the fuel can lead to sodium and potassium deposits when burned that are abrasive to the engine. The acid value is used to determine the amount of free fatty acids in the oil or fat, which in turn is used to calculate the exact amount of catalyst needed to make the biodiesel. Having too little catalyst can lead to an incomplete reaction resulting in fuel with too high levels of total glycerides. According to the ASTM specification, biodiesel can have no more than 5 ppm of sodium and potassium and no more than 0.24% total glycerides in the fuel sample. Titration is a chemical procedure that can be used to obtain this number. The acid value is the quantity of a known concentration of potassium hydroxide consumed by titrating a sample of oil or fat and is expressed in the units of milligrams of potassium hydroxide per gram of sample. Manual titration requires a color indicator such as phenolphthalein and organic solvents such as toluene or isopropyl alcohol to dissolve the sample in order to obtain a clean endpoint. Have on hand your color indicator, titration solvent, and standardized potassium hydroxide titrant. Instructions for standardizing the titrant are found in ASTM D664. Start the procedure by adding 100 milliliters of the titration solvent to a 250 milliliter Erlenmeyer flask. Add approximately 10 drops of phenolphthalein indicator solution. Pour a weighed sample of approximately 20 grams into the solvent. Titrate while stirring with potassium hydroxide titrant to the endpoint, which is a definite color change to orange or green-brown color that persists for at least 15 seconds. Record the milliliters of titrant consumed. In order to calculate the acid value, the following equation can be used. The acid value is equal to the volume of titrant used multiplied by the normality of the potassium hydroxide solution multiplied by 56.1, all divided by the mass of the sample. Again, the acid value is expressed as milligrams of potassium hydroxide per gram of sample. 56.1 is the molecular weight of potassium hydroxide. This works because the potassium hydroxide is a basic solution, which reacts with an acidic solution until all of the acid is consumed and the solution is neutral. Any potassium hydroxide added to the sample after it is neutral causes the solution to become basic and change color. To express this value as a percent of free fatty acids, divide the acid value by 2 if the fatty acid profile is mostly oleic, palmitic, or stearic acids. Oils with a high percentage of lauric acid, such as coconut, should be divided by 2.8. Note, this method can also be used to measure the acid value of the finished biodiesel. Sample size will be larger, and a weaker normality of potassium hydroxide should be used to achieve accurate results. Calculating extra catalyst. Note, the following was taken from Building a Successful Biodiesel Business by Van Gerpen et al. When feedstock acid value is greater than 2, extra catalyst should be added to account for what will be lost in forming soap. It takes 1 mole of catalyst to neutralize 1 mole of soap. The amount of additional catalyst can be calculated using the following formula based on the type of catalyst used. This figure is the amount of catalyst that should be added to the standard formula, which is based on the feedstock weight as follows. For example, when adding sodium methoxide, a feedstock with 1.5% free fatty acid, the amount of catalyst would be 1.5 times 0.190 plus 0.25% equaling 0.54% of the weight of oil or fat to be made into biodiesel. 1,000 pounds of 1.5% free fatty acid feedstock would require 5.40 pounds of sodium methoxide.